Hello everyone and welcome back. My name is Mr. Cobalt, and in this video we're going to go over how to uh, fill in the missing part of a nuclear equation. So we're going to go over some practice problems, and we're going to learn what we used in the previous video, where we know that the top numbers of one side must equal the top numbers on the other side of your arrow, as well as the bottom numbers. So the bottom numbers must be equal on both sides, and the top numbers must be equal on both sides. And so that's the total of each of those numbers. So let's get into this. So so problem number one, we're given Pu, plutonium, and 239, and it has an atomic number of 94. So remember, the top number is protons and neutrons, which is your mass number, and then your bottom number is your atomic number, which is the number of protons, which identifies the element Pu on the periodic table. So you're going to need to use your periodic table for this. So you have a periodic table so you can follow along with me. So basically we're just adding and subtracting, and we're figuring out what we need to balance the numbers that are of the missing element or particle. So when you're trying to figure out the missing piece, missing piece could be a particle that's emitted from the nucleus, or it could be a daughter isotope. So you got to figure out which one it is. Okay, so here we're given the alpha particle. So this is an alpha decay process. And so here probably is going to be our daughter isotope. So we're going to need to use our periodic table to figure out what the symbol is. So what you need to do is balance the top numbers and balance the bottom numbers so that the top numbers equal on both sides. So the total number on this side of the arrow should equal the total number on this side of the arrow. So I have 239 over here. So I'm thinking I have 4. Well, 4 plus what number is going to give me 239? So I can subtract 4 from 239 to get that number. So, or I can, just think about, okay, well, I have 4. What plus 4 gives me 239? And it's 235, right? So an easy way to do that is just take this number here, subtract it from the top number there, and you'll get that one, or the total over here. So 4 plus 235 gives me 239. Okay, so I have the top number of my missing isotope. The next, I do the same thing for the bottom. So here I have 2 for the number of protons, and here I have 94. So 2 plus what gives me 94? I want 94 total on this side. So 2 plus what number gives me 94? Well, that's 92. So 92 is our missing number. So 2 plus 92 gives me 94. Okay, so now what's the symbol? I have to look up number 92 on the periodic table. So number 92 on the periodic table, I'm looking at the atomic numbers, and 92 is uranium. So U, the symbol for uranium is a capital U. So I'm going to do a capital U here. So there's the equation. That's my missing isotope. So my daughter isotope is uranium-235. And so now I have a balanced equation. Let's try number 2. So number 2, they're giving me potassium-40. So the mass number is 40 and the atomic number is 19. And it's going to produce calcium-40. So here's my daughter isotope. So I need to figure out what particle was emitted. So again, I'm making sure that the total top numbers on the reactant side of the arrow, this side of the arrow, is equal to the total top numbers on the product side. So I have 40 here. 40 plus what gives me 40? Well, that would be 0, because if I subtract 40 from here, I get it 0. So 40 plus 0 gives me 40. Here, I have 19 for the bottom number, the number of protons, the atomic number. Here I have 20. So 20 plus what gives me 19? How do I get 19 from 20? Well, I got to subtract 1, right? So 20 minus 1 gives me 19. So here, I'm going to have a minus 1. So now that we have the top number and the bottom number, we can identify this particle. And so we would identify what particle has a mass number of 0 and a negative 1 charge. Well, that would be your beta particle. So you could do two ways to symbolize this. You could do E with a negative, right? Or another way you could symbolize this is with the beta symbol, strange looking B. So either one of these would be acceptable for the symbol for this beta particle. So here we have beta decay. So this would be an example of beta decay. Okay, now we have our next one, number 3. So we have AM, and the mass number is 241. So 241 protons and neutrons together, and it has 95 protons. So here's our parent isotope, and it's going to give rise to our daughter isotope. So notice it's NP, so the number of protons has changed. And you'll notice that 237 has changed from 241. So we need to figure out the numbers. So again, the total numbers on this side should equal the total numbers on this side. So the total is 241 here, and here we have 237. So 237 plus what number is going to give me 241? So what do I need to add to 237 to get 241? Well, that's 4. So I need to add 4 to 237 to get 241. Same thing for 95. So I have the bottom number, 95 here. So the total is 95. And that should equal the total on this side. So it's going to be 93 plus what gives me 95? Well, that's going to be 2. So 93 plus 2 is 95. So now that I know the numbers here, mass number, atomic number, now I can figure out what sort of decay this is, what particle is being emitted. And here, anything that has a mass number of 4 and a atomic number 2, we know that atomic number is related to the symbol. So if we look up atomic number 2, that's going to be helium. So the symbol is helium, and what do we call a helium nucleus? It's called an alpha particle. So this is an example of alpha decay, and we could again either use this symbol for an alpha particle, or we could do the same thing and just use your alpha symbol. So that's it for number 3. What about number 4? Now 4 and 5 gets a little bit more complicated. So here we have two things on the reactant side and one on the product side. So now we've been dealing with multiple on the product side, but you can have multiple on the reactant side too. And here we have the symbol for a neutron. So we're taking a neutron and we're bombarding rubidium 85 with the neutron. We're adding that to the nucleus, and then we're going to figure out what we get from there. So if we bombard this, remember the top numbers have to add up to the top numbers have to add up on this side as well as this side. So 85 plus 0 is 85. So this should be 85. 37 plus 1 is 38. And so we get those numbers there. So give me a sec. Okay, so made a mistake here. I switched these numbers around. So mass number should be 1 and 0 should be on the bottom there. I thought that was strange because the protons are changing, but this is a neutron, which makes no sense whatsoever. So let's try this again. So we have 1 for the mass number of a neutron, 0 for charge of the neutron. So we add these together. So 85 plus 1 gives me 86, and then 37 and 0 gives me 37. So that is much better, since the atomic number shouldn't change if you're adding a neutron. And so the element symbol is going to stay the same, since the 37 is the atomic number, the number of protons. And since the number of protons doesn't change, then the symbol is going to be the same. So here we have our B. So we've added a neutron, and we've made the mass number bigger. And so here would be our daughter isotope for this reaction here. And now finally we have number 5, we have NP. The top number is 238. So here we've got 2 things on this side, and we have 2 things on this side. So remember, the top numbers, the total for the top numbers on each side should equal to each other. So it's not just this one or this one, it's the total together. So 238 plus 0 is 238. So that means that whatever this number and this number should add up to the total of 238. So we have 4 here. 4 plus what gives me 238 total. And that's going to be 234. So we have 234. 234 plus 4 gives me 238. 238 plus 0 gives me 238, so it's balanced. Now, what about the bottom numbers? So here we have 93, and we have -1. So 93, -1 together is going to be 92. So over here it should equal 92 total. So this side, 93 and -1, is 92 total on the bottom. So the bottom number should add up to 92 as well. So 2 plus what gives me 92? It's going to be 90. So now I have my 2 numbers. I know the number of protons. So I look up that number on the periodic table. So I look up 90. And 90 is number 90 is thorium. So thorium, TH. And so here we now have our balanced nuclear equation. So I hope this was helpful. If this was helpful and really cleared up things for you and made things more understandable, please go ahead and like my channel, or like my video there. Subscribe to my channel. Hit that notification bell up there so you can be notified by other videos I put out. Put a comment down in the comment section. Let me know what you think. If you have any questions or comments, I love to hear from them, from you. Thanks for joining me. Have a great day.